Math 1, graphing systems of equations. Now, my suggestion is to use some sort of graphing function. So graphing calculator or Desmos is a great one, whether it's on your phone or the website, desmos.com. Okay, I would get used to using those. However, I'm going to do it by hand to show you how to do it by hand, but if not, you just type these into the calculator and find where they intersect to find that solution. Remember, that's the key here with systems of equations is what is the solution for both of them? What's the one or more points where they're the same, where they intersect? So we start by graphing the first one. Y-intercept is positive 4. These are in slope-intercept form. Slope is 3 over 4, so up 3 to the right 4, which I can kind of do. So 1, 2, 3 to the right 4. It's right about there. Or we can go backwards down 3 to the left 4. Okay, draw our line. And then we graph the second one. Y-intercept of negative 1. Slope of negative 1/2, so down 1 to the right 2. Or we can also go up 1 to the left 2. Okay. Oh, and I think I messed up on that one, didn't I? So there's that one. This one was at 4, and I went down 3 to the left 4. There we go. So, where's their solution? Where do they intersect? Right here, the point negative 4, 1. That's the solution to this system. It satisfies both equations. Okay, let's take a look at number 2 now. Y-intercept of positive 3, slope of 7 over 3, so I could go up 7 to the right 3, or I could go down 7 to the left 3. Which would probably be easier considering my answer should be somewhere on this little graph. Then negative 3 to start us off, slope of 1 over 3, so up 1 to the right 3, or down 1 to the left 3. Should be pretty apparent where my answer is, right there at negative 3, negative 4. So the solution to this system, the point that is the answer to both of them, is negative 3, negative 4. Okay, let's take a look at number 3 now. Positive 4 to start us off, slope of negative 1 over 4, so down 1 to the right 4, or up 1 to the left 4. There's our first line. Then negative 3 for our y-intercept, slope of 3 over 2, so up 3 to the right 2. And we can see where they intersect right there, which is x value of 4, y value of 3. So the solution to this system is 4, 3. That's the point. Number 4, positive 1 here, slope of negative 3, so down 3 to the right 1, or up 3 to the left 1. Second one, positive 4 for our y-intercept, slope negative 3 over 1, so down 3 to the right 1. Okay. Now we should notice on these two, and you could have seen this right off the bat, these are parallel lines, aren't they? They have the same exact slope, but different y-intercepts. So are they ever going to intersect? No, so we call that no solution. Sometimes that happens. These lines are never going to intersect, therefore their solutions are never going to be the same. Therefore, for the system, it's no solution. Okay, question 5. Now we introduced an exponential. So remember, exponentials, your y-intercept is right here at 4. Then we're times them by 2 each time. So as we go to the right, we're going to times by 2. Okay, if we went to the right one more, we'd times by 2 and be up here. As we go to the left, we would divide by 2. So as we go to the left one, we divide by 2 each time until we hit that end behavior of going to the x-axis. So it would look like this. Okay, then graph the linear, so positive 6. Then 5 over 2, we go up 5 to the right 1, or down to the left 1. Oh, to the left 2, sorry. To the right 2 and to the left 2. Because of that 2 underneath, huh? So we get a point right there. And then a point right about there. So we draw this line. And this is where it helps to have the software, because sometimes they don't always match up at a nice number. Now this one did. So one of the solutions was negative 2, 1. This other solution, not sure exactly where it was. Okay, so we'd have to guess. So I'll graph it with Desmos and kind of show you what that would look like so we can see that one better. Let's try number 6 now. So number 6, 2 to the x, so it would be like 1 times 2 to the x, so y-intercept of 1. So as we go to the right, we're doubling again, so 2, 4, 8, and so on. To the left, we cut it in half. So we go to that end behavior, so we go like this. Okay. Now, the second one, we have 1/2 to the x minus 1 plus 1. Okay. So a good way to deal with this one is to make a table. This plus 1 will actually bump it up 1. The y-intercept would be 1. So we should have a y-intercept at around 2. Okay, but this minus 1 actually throws it off 2. So let's graph it. So let's do 0, 1, actually, let's go negative 2, negative 1, 0, 1, and 2. So if I do a negative 2 in there, so 1/2 to the negative 2 minus 1 plus 1. So negative 2 minus 1 is negative 3. Now, we learned some rules at one point about these. A negative flips for the reciprocal, so it would be 2 over 1, or just 2, and gets rid of that, so it's 2 to the third plus 1. Well, 2 to the third, 2 times 2 times 2, that's 8, plus 1 would give us 9. So at negative 2, we go up to 9. Now let's do it with a negative 1. So if I did a negative 1, that would make this a negative 2, which would make this a positive 2, as we flipped it, which would make this a positive 4, which would make that a 5. So at negative 1, we go to 5. Now we do it at 0. So 0, so 0 minus 1 is negative 1. So that would be 1. So it would end up being 2 plus 1, which is 3. So 0, 3. Now we do it for 1. So 1/2 to the 1 minus 1 plus 1. Well, 1 minus 1 is 0. 1/2 to the 0. Anything to the 0 power is 1, so we get 1 plus 1, which is also known as 2. And then finally, number 2. So 1/2 to the 2 minus 1 plus 1. 2 minus 1 would be 1. 1/2 to the first would be 1/2 plus 1 would be 1/2 plus 1, which is 1.5. So it would be 2, 1.5. So right about there. So you can kind of see that basic shape. And it would keep going like that. But we can see where they intersect, can't we? At the point 2, 1. And because they're going in different directions, are actually 1, 2. X value of 1, Y value of 2. So that's the number, the point, that satisfies both of those. That's the solution. Now let's take a look at number 5. Let me do it in Desmos here. So you go to my calculator. I type in y equals 4 times 2 to the x. Okay, to get my first graph. Then y equals 5 divided by 2 times x plus 6. And the nice thing about Desmos is that it shows me where they intersect, and I can easily make that into a click on it to get those. So let me take a picture here, and I'll put it up on our stuff. So let's clear this off. Actually, let's just erase this so we can look at it with our own picture. Okay. Alright, so here we go. So here's our graph, as we can see. Okay, the colors are just swapped, but we had that one right, negative 2, 1, but it also crossed right here at 1.15, 8.874. So that's why having a graphing utility can help you out more so. And those would be our two solutions. When you're dealing with stuff that's not linear, sometimes you can have more than one solution. And there we go.